Hi everybody. Yes, Aurora, I'm wearing the headband for you. We are going to take some notes here. We're going to finish up part 5 on the back of page 29, and then we're going to do our word problems today. It's kind of exciting stuff. But let's turn to the back of page 29. We actually left off with C, but I want you to mark out D. That is not a good problem. So let's mark out D, and let's go straight to E. So we are going to do problem E. And again, we are on the back of page 29, part 5, problem E. As we discussed today, you cannot do solve a logarithmic equation if there are 2 logarithms on the same side. So what we need to do is put those together so we have just one logarithm. So instead of having 2 separate logarithms, I'm going to put those 2 together. Now you remember from today, we either put them together as a times multiplication or as a division. Since this is a plus sign, they're going to go together as a multiplication. So I need to multiply x plus 4 and x minus 4. Those 2 things need to be multiplied. Now, I know and you know that when you FOIL that, because that's a FOIL, you're going to get x squared minus 16. So, again, I took these 2 logarithms, smashed them together as a multiplication. So I FOILed them. X plus 4, x minus 4. Now, I only have 1 logarithm. Now it's solvable. I do my loop-de-loo thing. So 5 to the 2nd equals x squared minus 16. 5 to the 2nd is 25. I'll add 16 to the other side. What will that be? 41. And take the square root. Technically, I should do plus or minus, but since I can't have a negative root 41 up here, I'm only going to take the positive root. So the answer to the question is the square root of 41. Let's try the next one. This is F. We're going to do kind of the same thing, but it's a little bit different. Are you looking at F? You better be looking at F. What do you notice that's different about it? Well, there are not just 2 logarithms over here, but there's a logarithm over here. Now, having 1 logarithm on a side is not an issue. So I am not going to worry about this guy right now. I'm not going to worry about him. He's fine. He's over there all by himself. Having 1 logarithm, just like here, I had 1 logarithm and I managed it. It was great. Having 2 logarithms, though, is not a doable thing. I can't have 2 logarithms. So I'm going to smash those together into 1. Now again, I'm not messing with this one. I'm taking these 2 because they're on the same side of the equation, and I'm putting them together into 1 logarithm. How will they go together? Well, because that's a plus, stop. There's only 2 ways they can go together. You either times or you divide. In this case, because that's a plus, I'm going to times. So I'm going to times these 2 things, and that gives me 4x. Now I am not going to loop-de-loo this. I loop-de-loo them when they look like this, when there's 1 logarithm and a number over here, so I can do 5 to the 2nd, right? Okay, what am I going to do over here? I want you to think about it for a second. If the log of the red, log log of the red equals the log of the green, do you think you could draw a conclusion? If the log of this equals the log of this, it is exactly true that 4x equals x minus 1. If you have one logarithm, you have to loop-de-loo, okay? But if you have one on each side, you can just drop them out and say 4x equals x minus 1. So 3x equals negative 1, and x equals negative 1/3. And beep, 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 beep. Here come the extraneous radar again. Because look, if x is negative 1/3, if you put it right here, you'd be taking the log of a negative number. You cannot do that. We've watched it on our calculator. If you try to take the log of a negative number, extraneous roots get me all shook up. If you take the log of a negative number, your calculator says error. It's not possible. So we cannot have a negative 1/3. So therefore, this problem has no solution. There's no solution to that problem because the only answer turned out to be extraneous. All right, what was that, F? So now we're on to G. Let's take a look at G. See what's going on here. Now, we got logarithms all over the place, but again, I'm not worried about this one. I am allowed to have one logarithm on a side. There's one logarithm on the right-hand side. No problem, don't worry about it. Over here, though, there's two. You can't have two. So these are going to have to go together. These two are going to have to go together into one logarithm. You're going to smash them together. I've said it over and over, I'll say it again. When you put them together, you're either going to multiply or you're going to divide. That's it. Those are your choices. Well, look what we got right here. A minus sign. What does that mean? That means when I put them together, I'm going to put them together as a division. So 2x divided by 3. 2x divided by 3. When you put them together, they go together as a division problem. Now, see what we got going on? This is not a loop-de-loop. We got the log of the green equal to the log of the red. And when you've got a log on this side and a log on this side, you just ignore them. They're gone. So 2x over 3 equals 5. 2x equals 15. And x equals 15 halves, or if you prefer, 7.5. That is not an extraneous root. If I plug it back in up here, I'm not taking the log of a negative. It's a perfectly fine answer. There it is, right there. X equals 7.5. Well, we only have one more, though, so let's try this one, see how we do. This is problem H. Now, notice all these problems have a different base. We have base 5, base 3, base 13, base 7. Doesn't matter. Doesn't matter. The rules are the rules. Everything stays the same. What does matter is that all the bases are the same. So as long as in the problem they're all the same, and they will be. I'm not going to try to trick you. I'm not going to mess you up. Your bases are all going to be the same. All right, so again, here's a problem. I need to put those two together into one logarithm. This one over here is fine. These have to be put together. All right, how am I going to put them together? Here are your choices. You're going to multiply 3 and x, or you're going to divide 3 and x. Well, see that sign right there? I'm going to divide 3 and x. Now look, are we going to loop-de-loo? No. We loop-de-loo if we had a problem like this. Then we would loop-de-loo. We would say 13 to the second equals this. That's when we loop-de-loo. When you have one logarithm equal to a number. This is not a logarithm equal to a number. It's 2 logarithms. What do we do when we got a logarithm on both sides? We ignore them. So 3 over x equals 12. Now I have to solve that. So 3 equals 12x, multiplying the x over here. Now I'll divide, so I get 3/12, which I will reduce to 1/4. Done. Good work. Good work. Now, our last and final piece of chapter 3 is really the most fun piece because you're going to do some actual real life problems. There are 2 formulas that you are going to be required to know. Memorize. The formulas you may have seen before. This we fondly call the PERT formula. And this is the formula for continuous or natural growth. In the PERT formula, and I hope you're writing this down, because the first thing we're going to have to do on every one of these problems is figure out which formula we're going to use. They're all doable with the 2 formulas we're going to talk about. All right, if the problem is a continuous or a natural growth problem, A stands for the amount at the end. So it's the ending amount. These are growth problems, so you're starting with something and ending with something. A is the ending amount. P is the starting amount. E is E, like ln log base E. E is that constant, Euler's constant. It's not a variable. It's going to be, every time you use this formula, you're going to have an E in it. R is the growth constant. Sort of like in those problems we were doing before where you had to determine if something was a growth or decay equation, and then you had to determine what was the percent growth. That would be that number right there. So this is going to be a decimal, like 0.02 would be 2%. And T is time. So I'm going to go down to problem number 3. I'm going to do these in a little bit different order. I'm going to do all the problems that involve this formula first, so we get some good practice with this formula. So I'm going down to problem number 3. How long will it take a population of 450 geosites to double if their growth constant is 0.123? Now, how do I know this is my formula? Well, the bacteria is made up, I called them geosites, but this is a natural problem. This is a population problem. It's nature, real world, not artificial, which is what you'll see in some of the other problems. This is a natural growth problem. So here we go. How long, all right, so this is my formula, and I am going to start plugging stuff in. How long will it take for a population of 450 geosites to double? All right, stop and think about that for a minute. 450 geosites to double. How many am I starting with? starting number, right here, P. I'm starting with 450 of them. If the population is doubling, how many am I ending up with? 900. There's my E. E is not a variable. E is E. R, my growth constant. Do I know what that is? Yeah, my growth constant is 0.123. What's T? I don't know. What does the question ask me for? How long will it take? That's my variable. T is my variable. We solved problems like this in class today. They weren't word problems, they were just random equations, but we solved them. Remember what the first step is? What's the first thing I have to do to solve this equation? First thing I need to do is divide by that. That has got to go. So I'm going to divide both sides by 450. Oh, that's just 2. It makes sense that that's 2 because we doubled, right? We doubled. Now, how in the world am I going to get that T down? It is an exponent. How am I going to solve this? Do you remember? We did it today. We did it earlier today. All we need to do is ln both sides. Now, gang, tell me what happens when I ln E. What happens right here? That's gone. So ln 2 equals 0.123t, and t equals ln 2 divided by 0.123. Don't forget your parentheses around the 2. Let's type it in, see what we come up with. ln 2 divided by 0.123, and I got 5.635. Did it give me a time unit at all? No. This should be 5.635 days or minutes or years. I don't know. I'm just going to say days. I'm making that up because I didn't write a very good problem. I should have indicated that in there, but I didn't. So there's some kind of time unit here. It might be months, it might be weeks, it might be years, I don't know. But there's a time unit on this number. How long will it take? It will take 5.635 days. Okay. All right. Number 4. Same formula. Read number 4 and tell me how I know it's the same formula. It is not a population problem, it's a money problem. But what is the key word in the problem? How much do I need to deposit in an account paying 4% interest compounded continuously? If the word continuous is in the problem, you're using PERT. How much, so let's fill in the numbers now. We gotta fill in stuff. How much do I need to deposit in an account paying 4% compounded continuously if I want to have $35,000 in 10 years? Okay, so where do I put the 35,000? If you said A, you're right, because isn't 35,000 what you want to end up with? It is. Now what's P? How much am I starting with? Oh, I don't know. That's my variable. There's my E. What's my interest rate? My growth constant. 4%, so I'll put in 0.04. What is my time period? 10 years, I'll put in 10. So 35,000 equals PE to the 0.4 power. I'm going to go ahead and multiply that together. 0.04 times 10, those will be multiplied. Now at this point, kids often make a mistake. Please, please do not put logarithms into your problem. Do not ln both sides. There is a huge difference between this equation and this equation. Notice, where is the variable in this equation? In the exponent. When the variable is an exponent, you ln, or you log. You use logarithms, okay? Is the variable an exponent here? No. It's easy to get p by itself. It's easy to figure out what p is. I just have to divide by e to the 0.4. So p is going to equal 35,000 divided by e to the 0.4. I just divide this off. So I have my p by myself. Now, how do I type that in? Well, I type 35,000 divided by. Now, if you look at your ln button, right above the ln button, see how it says e to the x? That's what you want, right? You want an e. So press second ln, and now you should have your e, and it wants to know, okay, what power am I going to raise it to? 0.4. And the answer is $23,461.20. Remember what the question was. The question was, if you want to end up with $35,000 in 10 years, how much do you have to deposit right now? That's what you would have to deposit right now. Yeah, okay. All right, I'll leave my formula there. Let's see if I have any on the back. Oh, yes, I do. I have a whole bunch on the back. Number 5. Find the decay constant of an element if its half-life is 10.2 years. Now, this formula can be used not only for growth, positive growth, but also for negative growth, which we call decay. Alrighty? So, excuse me while I get a drink. I got something in my throat. So I'm going to go ahead and use this formula. Here we go. A little tricky. Find the decay constant. So this is going to be my variable. All right? That means I need to plug a number in for the end, for the beginning, and for the time. Now, I think the time is easy because I got it 10.2 years, so that sounds like time to me. So I've got e to the 10.2r. T is 10.2 years. R is my variable, and there's my e. Now, I need to figure out what I'm putting in to start with, what I'm starting with, and what I'm ending with. The key here, gang, is half-life. You recall from chemistry that half-life means how long it takes to end up with half of what you started with. They did not tell me how much to start with, so I get to make up my own number. So I'm going to start with 100 grams of this stuff. I'm making that up totally. It's fine. Make up whatever number you want. Use your favorite number. If I start with 100 though, and I'm doing half-life, how much do I have to end up with? Exactly half of it. So if you want to start with 16, then you're going to end up with 8. If you want to start with 6, you're going to end up with 3. Now you're thinking to yourself, Mrs. Ford, how can this be? How can you just make up a number? Remember, what's the first step to solving the problem? The first step to solving the problem is dividing by this number. When I divide by that number, what do I end up with over here? 0.5, 1/2. Do you see how it doesn't matter what these original numbers were? every time I divide, if I'm doing half-life, every time I divide, I'm just going to have a half here. If you put 6 and 3, when you divide it, you're going to get a half. So on these half-life problems, you're going to make up your own starting point. Okay, so 0.5 equals e to the 10.2r. Now where's your variable? In the exponent. What did I tell you about that? The only way to solve it is to use logarithms, right? This is an e problem. So let's ln both sides. So ln 0.5 equals 10.2r. Remember, kids, ln e, gone. So all I need to do now is divide ln 0.5 by 10.2. So I'm going to do that. Don't forget the parentheses around the 0.5. So ln 0.5 divided by 10.2. I got a negative 0.068. Now wait a minute. A negative r value. Now what did we say r was? R is our growth constant. What does it mean when the growth constant is negative? It means we're decaying. Negative growth. We're shrinking. Instead of getting bigger, we're shrinking. Which makes sense because this is a half-life problem. We're ending up with less than we started with. We're shrinking. So we have a negative growth constant. Gotta admit, that's pretty awesome stuff. Look at number 6. Number 6, same formula because this now is trigites. A population of trigites is growing, and we want to know how long it's going to take. For 193 of them to become 391. Now, you guys, listen to me. You've got to be careful. Your starting number goes here. So it says 193 are growing into or becoming 391. And all I know is my R is 222. And I want to know how long it takes. There's my variable. There's my variable. What is the first thing I'm going to do? Oh, by now you better know this. The first thing you're going to do is get rid of that guy. Just like we did it here, just like we did it in the last problems we did. So we're going to divide by 193. Now don't be scared of that fraction. We're going to type it in our calculator. It's no big deal. Where's the variable though? It's in an exponent. How do we handle it when it's in the exponent? We ln both sides. So ln this fraction, ln e gone, 0.222t. So what's t going to be? This right here, whatever ln that fraction is. You can type it in, but I don't want you rounding it off, so be careful. We're going to take this number right here, and we're going to divide it by the 0.222, right? So I'm going to type that in, careful with my parentheses, 391 divided by 193 parentheses. And the answer is 3.180. Is there a unit on that one? No. So again, this time I'll say months. There's a time unit on this. We got to make sure we're labeling our problems. I just didn't write very good problems. So there's a time unit. It's how long will it take. So it could be days, it could be months, it could be years, minutes, seconds, who knows. But if there's a time unit on that problem. And number 8 is another example of this formula. How do I know number 8 is this formula? What word is in there? Compounded continuously. You got to read your problem carefully, guys. If it says compounded continuously, it's this formula. if it is a population growing or shrinking, it's this formula. All right, so here we go. What interest rate will be required to end up with 1,000 if I started with 890 and waited 3 years? So my variable is the interest rate, or the growth constant, 17%. That is my variable. Step 1, divide 1,000 by 890. Every time we're going to divide. Do I need ln this time? Am I going to ln this time? You betcha I am, because where's my variable? In the exponent. So I'm going to ln both sides. So I have 1,000 over 890 equals 3r. R is going to be ln 1,000 over 890 divided by 3. So I'm going to take the logarithm of that fraction and divide it by 3. And it's going to take me, or no, it's going to, I need an interest rate of 0.0388, which if you were going, just talking to somebody at the bank, they would say that's 3.88%. Now, I am fine with this answer, but it is an interest rate, so we're kind of used to expressing it as a percentage. So either one of those is fine. That's the interest rate that it would require. Okay. Now, I've got to wrap up here with the last problem, so I can't remember. I need to look through which ones we need to do, because now we're going to have a brand new formula. Okay, here is the new formula. This is an R, this is an N. Okay, and this is my formula for any compound interest problem except continuous. If it's if it's compounded continuously, we know we use our PERT formula. This is for any other compound interest problem. So when I look at number 1, how long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? So it's a compound interest problem, but it's not continuous. It's compounded quarterly, which means 4 times a year. All right, so I'm going to do problem number 1 with this formula. I'm going to show you how it works. Now, the good news is the A and the P stand for what they stood for before. So it says we want to start with an investment of 1,000. So P is going to be 1,000. But we want it to double. So we're going to end up with 2,000. A is the end amount. P is the start amount. Just like before. No difference. No difference. That is a 1. A number 1. So obviously that's not changing. I bet you can guess what R stands for. R is the interest rate. This says the bank pays 2.5%. What decimal is going to go in here? 0.025. 2.5%. This is the interest rate. R is the interest rate. You've got to be able to convert the decimal to or the percent to a decimal. So 2.5%, 0.025. Now, here comes the kind of new part. This N and this N are the same. They're exactly the same. And they are the number of times per year that you're compounding. okay? So, what I mean by that is, this problem says compounded quarterly. Quarterly means 4 times a year. So you're going to have a 4 here and a 4 here. There's 2 n's. And n is however many times you're compounding. So quarterly is 4, monthly would be 12, yearly would be 1. Pardon me? I have a phone, yeah. Oh, no, I don't have, I'm sorry. Oh, shoot, I'm sorry. Okay. So now, oh, what's the question? How long will it take? So T is the number of years. So we are going to find out how long it's going to take. Alrighty? Now, do you have any idea what the first step is? You better know, because we do it in every single problem. We're going to divide. So when I divide, I'm just going to get 2, because I'm going to divide by 1,000. And then I'm going to go ahead and simplify that. That's kind of a mess. So I'm going to go ahead and simplify it. 1 plus 0.025 divided by 4. And that turns out to be 1.00625 to the 4t. All right, so I did a couple of things. The first thing I did was divide by 1,000. And I went ahead and simplified this parentheses because it's a little messy. It's still kind of messy, I guess. Now, where's my exponent? Where's my variable? It's in the exponent, which means I'm going to take the logarithm of both sides. Now, nothing cancels. I don't have an LNE situation. However, the reason I took the logarithm is so that this would come out in front. So now I have the log of 2 equals 4t times the log of 1.00625. Remember, the beauty of logarithms is, if you take the log of something to a power, the power gets plucked off out in front. Let's divide both sides by the log. We did this already. You've done this kind of problem before. You've got to make sure that 2's in parentheses. So log 2 divided by log 1.00625. So this is 111.24976 and so on. I'm going to leave that on my calculator. I know I wrote it down, but just so we could look at it. But it's right here on my calculator. So I divided that off, so now all I have over here is 4t, and I did that division, and I got that decimal. So what do I need to do to figure out t? I need to take the number on my calculator and hit divided by 4. And the answer is 27.81 years. How long will it take to double your money? It'll take 27.8 years. Look at question 2. Am I going to use this formula for question 2? Yes. How do you know? Compounded monthly. That's exactly right. So I'm going to erase this guy right here. These problems take up a lot of space. How much will be in the account at the end of 10 years if $1,230 is invested at 3.125% compounded monthly? So remember, here are all of your variables. You have an A, a P, an R, an N, and a T. Now all that but one should be in the problem. How much will be in the account at the end? You're looking for A, people. You want to know what's going to happen at the end. What's my P? 1,230. That's a 1, remember. What's my interest rate? Decimal now, decimal, 0.03125. What's my N? How many times a year am I compounding? Monthly. So that would be 12. How long is this happening? 10 years? Let's go ahead and make that a 120. 12 times 10. Wait a minute. Where's my variable? Is it an exponent? No. You're not going to do logarithms. You're going to type this in. And boys and girls, you're going to type it in exactly like that. Type what I tell you to type. 1230 parentheses. 1 plus 0.03125 divided by 12 close parentheses. In other words, I just typed in what's in that parentheses. Now I'm going to raise it using my little caret button, using this button right here. I'm going to raise it to the 120th power. And the answer is $1,680.53. If you didn't get that, then you did not type in exactly what is written. Type in exactly what is written. 1230 parentheses, 1 plus 0.03125 divided by 12 parentheses, raised to the 120th, and this is what you will get. There should be one more. Yep, look at number 7. Number 7. How much will I have in my, oh, first of all, how do I know I'm using this formula? Compounded monthly? Yeah. Anytime it's compound interest, unless it says continuous, you're using this formula. This formula is only used for money. If it's a half-life, if it's a trigite, any kind of bacteria, any kind of population, it is going to be the PERT formula. This one is only used for compound interest. All right, so here we go. How much will I end up with if I start with 555 at an interest rate of 3.5, compounded monthly for 12 years? I don't know if you can see that. Let me write it again. It might be off the screen. So I have 555, 1 plus 0.035 over 12 to the 12 times 12. Now let's make sure everybody's clear where all these numbers come from. A is what I'm ending up with. That's the question. P is what I started with. Tells me I start with 555. 1 plus interest rate 3.5%, 0.035. Compounded monthly, so N is 12, both places. This is the 12 years. So I'm going to make that a 144. Do I need logarithms? No, this is exactly like the last one. Groupies, when do you need logarithms? When your variable is up here. If your variable is not up there, do not use logarithms. Just type it in. So here we go, one more time. 555, parentheses, 1 plus 0.035 divided by 12, close the parentheses. Raised to the 144th power equals, the answer is $844.17. And that, my friends, concludes chapter 3. Next time we're together, we will jump in on our practice tests. Have a great day.